Welcome back to my math channel. Today we're going to be looking at solving systems of equations, linear equations. This is usually around 10th grade when we learn these. And a system is really just more than one equation. We want to simultaneously solve them so we know in our mind that the answer is going to be an ordered pair. It's an XY combination, okay? So we need an X and we need a Y. And the X and the Y, when they get plugged into both of these equations, will simultaneously make the left-hand sides equal to the right. Graphically, we could graph these, okay, if you wanted to graph them on some graph paper, and the point of intersection is the solution. Another way we could do this is by substitution, but today what we're going to do is look at it using a method called elimination, or sometimes it's called addition subtraction. So if I look at these two equations, notice that they're all sort of lined up. So my x's are lined up in an organized way, my y's, the equals, and the numbers. When you have them like that, just check and see if you could add these together to eliminate one of the variables. So notice I've got a -4 here and a +4 there. If I was to vertically add these would go away because -4x plus 4x is 0x, which I'm not going to write. So these actually eliminate. The x variable eliminates. So you watch for cases where the coefficients are opposites, and elimination is usually the best way to go. Then I'm going to add vertically the y's. So -2y plus 8y is 6y. Line up your equals, keep your equals in line, and then -12, -24 is -36. And you can see what's happened here. The original two equation system has basically boiled down to a single equation system and one unknown. And we can solve for y here by simply dividing by 6. So this tells us that y is equal to -6. That's great because now look, we already have half of our answer, but we need to get the x. So all we do, this is pretty easy, you're going to like this, take the -6 and plug it back into either one of the original equations. You just choose the one that you hate the least, I guess. So for no particular reason, I'm just going to take this one here, the lower one. So 4x plus 8. Now that's a y. This gives me the opportunity to plug the y value into the y variable. Equals -24. I'm using the second equation. You could have used the first. And I'm simply going to drop the -6, because we just found that y is -6, into that equation. And then I'm going to solve for x. This is pretty easy now for you. So this is 4x. 8 times -6 is -48, equals -24. Now I want to solve for x. So this isn't too bad. I'm simply going to add 48 to both sides. And that's going to eliminate that and get rid of the -48. And then last but not least, that means that 4x is equal to 24. And divide by 4, just like you're solving a basic equation, a single equation. And this tells me that, well, 24 is divisible by 4 6 times. So the x is 6. Make sure that you write your final answer, though. I'll make it in purple. So my final answer, I like to say therefore, is, write it as an ordered pair, okay? So the x was found to be 6, and the y was found to be -6, and put a big old box around the answer, and make sure that you have a visualization. If you were to graph these two equations on a grid pattern, they would intersect. The points of intersection, the point of intersection would be at the location 6, -6. Now, the other thing that your teacher may require you to do is to verify the answer. So you take the x coordinate and you put it where the x is in both cases. So both of the original blue equations have to be checked. So 6, you put 6 where the x is. So that's going to be -4 times 6, which is -24. And then now take the y, which is -6. Put the -6 here. -6 times -2 is +12. And that is equal to -12. which it checks out. So you're happy. This means that that works for the first equation. Now be careful. Just because it works for the first equation doesn't mean it works for the second. So try the second one. So where you see the x, put the 6. So 4 times 6 is 24. And then take the negative 6 and put it where the y is. 8 times negative 6 is negative 48. And 24 minus 48 is negative 24. And you're happy again because it's equal to negative 24. So we know that the ordered pair that we found balances both equations simultaneously, so it's a solution to the system of equations. Okay, so sometimes when you get your two equations, 1 and 2, you may notice that the coefficients on the x's or the y's aren't opposites or close to each other. So you may have to do some preliminary work to use this method of elimination. So let's suppose I want to eliminate the x. I can still do it. I know that if that was a 4, then I could add them and then the x would be eliminated. So what I could do is multiply the second equation by 4. And so if I go right through, I'm going to multiply through by 4. Notice both sides of the equation get multiplied by 4. So 4 times x is 4x. 4 times negative 3y is negative 12y. Keep your equals lined up, don't lose your equals. 4 times negative 6 is negative 24. And so that's sort of the new version of the blue second equation. These are identical. If you were to graph this red graph, and if you were to graph this blue graph, they would be the identical thing. So you can multiply through by a number if you want to. Now take a look. I'm going to take the second one and write it below. Sorry, the first one and write it below, plus 9y equals 9. I like to have them sort of stacked together. And now I can add vertically like I did in the previous one. So I'm going to add these two equations together. These are going to cancel. 4x minus 4x is 0x, or just 0, 0. I'm not going to write 0. Save the lead. And then negative 12y plus 9y is negative 3y. Line up your equal signs. Don't forget to do that. And negative 24 plus 9 is negative 15. Okay? Then now you've got this new equation, this third equation. It's in one variable, so you can solve for it. So I'm going to divide both sides by negative 3, divide by the coefficient. What you do to one side, you have to do to the other. That's a 3, by the way. And then write your answer. So those cancel. Y turns out to be positive 5. So don't forget, we're gearing up to write our answer as an ordered pair. The answer has to be written like that. We have the y coordinate. We have half our answer. How do we get the other one? Well, you know, take the y value that you just solved for and plug it back into either one of the original equations. I'm going to choose the second one because it looks smaller before I multiplied by 4. So I'm going to take the equation. I'm going to write it down. So x minus 3 times y. Well, y was found out to be 5. Equals negative 6. Do you see what I'm doing? I'm taking the y value and I'm plugging it back into either one of the originals and then solving for the x. So the y value here turned out to be 5. And now it's just a little bit of arithmetic. So now I've got x minus 3 times 5, which is x minus 15, equals negative 6. And then simply move the 15 over to the other side, or think of adding 15 to both sides. What I do to one side, I do to the other. And so x turns out to be, well, negative 6 plus 15 is 9. So I get the answer for x to be 9. So I like to do a big therefore. So therefore the answer is 9 comma 5. Put a box around it so your teacher can see that. And then just double check to make sure that it's correct. So if I take the x, which is 9, and I put it here, and I take the y, which is 5, and I put it here, and I do a little bit of arithmetic on this side, some bed mass, it has to equal 9. So let's check it out. So negative 4 times 9 is negative 36, and 5 times 5 is 45. Well, did you know that 45 minus 36 is actually equal to 9? So that's good. Check with your teacher. Sometimes your teacher wants you to show these checks more formally, and then sometimes they just want you to verify to make sure that the answer works. Then take the 9 for here, put it here, and take the 5 and put it here, right? and then do some bed math. So 3 times 5 is 15. 9 minus 15 is -6. You're happy. This makes you happy because this answer balanced both equations at the same time. Okay, so that's the way that we go about doing something called elimination. It's one of a few methods to solve systems of linear equations. And don't forget that this answer represents the point of intersection when those original blue lines are put on a graph. They'll meet at this location. If this video helped you at all, slap a like on it. Don't forget to subscribe to my channel for lots and lots of math videos to come. And share this with someone if you think it might help them. And I'll see you right back here in the next video.